So this is chapter or section 3.3, right? And we're trying to find all the zeros of a polynomial function. Here we're given, we're given one of these zeros. And this is the example that we couldn't get to in class. This was the last example. So this would complete your notes. All right, so find all the zeros of f of x equals x to the fourth minus 7x cubed plus 18x squared minus 22x plus 12, given that 1 minus I is a 0. All right, so is a 0, right? Then that means that we're saying x is equal to 1 minus I, right? When it tells us it is a 0, it means that x equals that, right? Well, according to the, complex conjugates theorem, so then anytime you have an imaginary or irrational solution, there's always two of those, right? If you think about how do we get i's in the first place? I is just the square root of -1, right? But remember, if you think about quadratic formula, when you take the square root, it's not just one square root. Anytime you create a square root, in order to get the solution, there would have to have been a square root that was created, which means there's a plus and a minus. So we're going to have, conjugates, meaning there's one with a positive and one with a negative. Normally if we say x equals a, then we'd also have x equals -a, right? Those would be the solution. So in this situation, we'd have x equals 1 plus I would be your, because the square root, the I came from the square root, and there'd be a plus or minus. Maybe we have, negative b in this case. Maybe it was just, 1, and it'd say 1 plus or minus the square root of -1. Here would be the plus version, and here would be the minus version, right? But there's going to be two of them. Now, if they give you one, the other one's understood. So they gave us one. They get this one was given, and this one is understood. All right, so make sure you don't fall for the trap of being like, what do I do after I do that once? So because this is a 4th degree polynomial, the idea is that we want to get it back to a 2nd degree polynomial, which means we need to do synthetic division on it twice. The first time would knock it down to a cubic function or a 3rd degree polynomial, and then the second time we do synthetic division, we would knock it down to a, quadratic or 2nd degree polynomial. So you're going to be doing the compound synthetic division. I don't know why this is wanting to highlight everything, but let's start it. All right, so first synthetic division, since we're using synthetic division, we look at the powers. I see that's 4, 3, 2, then this is 1, and then this one, you could say x to the 0. All right, so we're good there. We don't have to put in any placeholders. So I'm saying with my solution, I have 1 minus I, and that's going to be, what I set up. And then I have 1, -7, 18, -22, and 12. And let's see how this goes. The 1 comes down. 1 times 1 minus I is 1 minus I. And then I add those together. Well, the -7 would add to the 1, and that would become -6 minus I. And then I would multiply these together. So -6 minus I times 1 minus I. I'd probably do that underneath it. I wouldn't want to try to do that all at once there. So we'll say -6 minus I. I'll do box method 1 minus I. All right, so 1 times -6 is -6. 1 times -I is -I. -6 times -I would be 6I. And then -I times -I would be positive I squared. We got to remember that I squared is equal to -1. So this is going to give us -7 and then plus 5I. So that's when I multiply that, that's what I get. -7 plus 5I. And then I add these together. So 18 plus -7 would be 11. And then I'm just bringing down my 5I. And then I multiply them. 11 plus 5I times x minus 1. So 11 plus 5I. And then I said x minus 1, but 1 minus I. All right, 11 times 1 is 11. 1 times 5I is 5I. Negative I times 11 is -11I. And then negative I times 5I would be -5I squared. Remember, I squared is -1, so this gives me 5. This means I'm saying 5 plus 11, which is going to give me 16. And then 11I minus, or -11I plus 5I would give me -6I. So that's what goes here. 16 minus 6I. All right, I add those together. -22 plus 16 would be -6. And then I'm saying minus 6I. All right, got to do the same thing again. I'll change colors. -6 minus 6I. It's going to be multiplied by 1 minus I. That's -6, -6I, positive 6I, positive 6I, and then this would be 6I squared, which is -6, right? Because I squared is -1. This cancels, this gives me -12. All right, because you're adding them together, right? -12, man, that's crazy how that worked out. That gave me 0. So that just tells me that, x equals 1 minus I is a solution. Which the problem already told us that. All right, I'm going to erase some of this stuff so I can do my compound synthetic division. All right, so now we're bringing in, we just did what's given, but now we're doing what's understood. So now if I'm going to bring that in and do compound synthetic division and say, all right, that's going to be 1 plus I. And you'll see that this one isn't as bad, right? So we bring the first down, and that's 1. 1 times 1 plus I is just 1 plus I. All right, we add those together. We get -6 plus 1, which is -5, and -I plus I, well, that's just -5 still. All right, so -5 times 1 plus 5I, well, we just say that's going to be -5 minus 5I. All right, and then we add those together. 11 plus -5 would be 6, and then 5I minus 5I, no more i's, right, on that. And then we got 6 times 1 plus I, and that's 6 plus 6I. Then we add those together, right? That cancels out to give you 0. So now we know that x equals 1 plus I is a solution. That is a solution, that's understood, right? It's not like we're discovering something new. That's understood by the complex conjugates theorem. So now we can start trying to discover something new with this. So let's kind of go back and review. This was a 4th degree polynomial. We divided a factor out of it, or a solution. We divided a solution out of it. And then we were given this thing, right? We divided another solution out of this, and we were given this thing, right? And now we have, that means that it's a quadratic. So this is x squared minus 5x plus 6. Well, I can factor this. So that's, what two numbers can I multiply together to get 6 that I can also add together to get -5? That's -2 and -3. All right, so x equals, or I'll do it step by step. X minus 2 equals 0, because we could set this whole thing equal to 0. X minus 3 equals 0, so x equals 2, x equals 3. So what did the question want to know? Find all the zeros. So all the zeros of this function are x equals 2, x equals 3, x equals 1 plus I, and x equals 1 minus I. That's all 4 zeros. It's a fourth degree function, and there are 4 zeros. Once again, you have to do this problem like this because, well, there's shortcuts to everything, but I wouldn't be recommending them. But remember, imaginary zeros are not on x-axis. They don't show up on the x-axis. All right.